power series so a power series is a series of the form so like this, sum n equals 0 to infinity, so Cn, there's a term, times x minus a power n. Okay, so there's an x now. We never had an x before. Okay, so now in my series is going to be an x. And what's going to happen here is I'm going to try to determine the values of x for which this series converges. Okay, so up until now we had a series normal, we determined it converges or diverges. Now there's a variable inside, and this variable, depending on the value of that variable, the series will converge or diverge. Okay, so V, what we call, that's an important word here, V, and that's what we're going to have to find. The interval of convergence of the series is the set of values of x for which the series converges. Okay, so the interval will be something like this, from A to B. Okay, oh no, I'm not going to use A because I used A here. Or actually, you know what? I'm going to use K here. Okay, I'm going to use K. So change this to K. Okay, and so the interval of convergence is from A to B. I don't know if A and B are included or not. Who cares? Let's include it just for the example, let's say. Okay, so it will be a certain interval of values of x for which the series converges. Okay, and the radius of convergence, another definition, is, well, R is equal, can you still see it? R is equal to, so it's basically the half the length of the interval. So you do the length of the interval, B minus A, and you divide it by 2. That will give you the radius of convergence, okay? Always. Okay, so it sounds much more complicated than what it is, okay? So the best way is to do an example, okay? And find the interval of convergence and the radius of convergence of a series. Okay, so let me set you up with an example. find the interval of convergence and the radius of convergence of the series. So let me find one quickly. Let's do first one. Sum n equals from 0 to infinity, -1 power n times x minus 2 power n over, let's say, 3n plus 1. Okay, so if you see my Cn, here my Cn would be what? -1 power n over 3n plus 1. It's all the term that does not have the x. And in this case, x minus 2, x minus k power n power n. So in this case, the k is 2 and the x is right here.
Could you repeat that, please?
Yeah. In this case here, if you want to recognize the structure, right, of the series, just like you have here, well, Cn, well, you have x minus k power n, x minus 2 power n. Okay, so I see it. I see that term. And all the rest only depends on n. That's my Cn. In this case, my Cn is -1 power n over 3n plus 1. Good?
Yeah, thank you.
Okay, so what am I looking for? I'm looking for the values of x that make this series convergent. Okay, the values of x that make this series convergent. So what I'm going to do, I'm going to use the ratio test. And I'm going to say if the limit as n approaches infinity of an plus 1 over an is less than 1, this series will converge. Okay, so I'm going to write this down. The series converges if, right, the limit as n approaches infinity of an plus 1 over an in absolute value is less than 1. Right, this we know. This is what we said was the ratio test, right? So let's ask for this limit to be less than 1. Let's do it, okay? So limit as n approaches infinity of the absolute value of -1 power n plus 1 times x minus 2 power n plus 1 over 3 times n plus 1 plus 1. Okay, that's an plus 1 divided by an, or times an flipped. So times 3n plus 1 over -1 power n times x minus 2 power n. This has to be less than 1. Any questions on what I just wrote?
So we use the ratio test to like find the value of this, and
Of
the
x.
interval will be from this value to 1.
No, no. I'm asking. I'm saying that this series will converge if this limit is less than 1. And now I'm going to try to find, using this inequality, I'm going to try to find the values of x that make this less than 1, basically. Okay? So let's simplify the inside here. If I'm going too fast, please stop me, okay? This has to be less than. Yeah.
The denominator in the first one, you added -1 to the power of n and x minus 2n to make it an, right? On the denominator, when you added -1 to the power of n and x minus 2 to the power of n.
Yeah, that's an on the bottom.
Yeah, you just added that to make that an, right? Because if not, it was just 3n plus. Okay.
This term here, this term right here, the 3n plus 1 minus 1 power n x minus 2 is just 1 over an. I'm multiplying by 1 over n.
Yeah.
Okay. All right. So let's simplify this. So -1 power n times -1. Then here I have x minus 2 power n times x minus 2. Here I have 3n plus 1. And on the bottom, I have 3n plus 4, -1 power n, x minus 2 power n. Okay, so these are x's. Just fix them. Okay, that's also an x. Can you see, or it's too small?
You can see it fine.
Okay. And now it's time to clean everything up. -1 power n, -1 power n is out. X minus 2 power n, x minus 2 power n is out. And what am I left with? -1. Well, the -1 really, I don't really care about this one because anyways, we're in absolute value. So whether you multiply by -1 or not, you'll get the same answer because it's going to disappear when I do the absolute value of -1. So this I could disregard since I'm in absolute value. Equals. And now what does not depend on n, I could pull out of the limit, which in this case is x minus 2, right? The x minus 2 does not depend on n, so I could take it outside of the limit. So x minus 2 is outside, okay? But of course, it comes with an absolute value, still an absolute value, times limit n approaches infinity of what's left, 3n plus 1 over 3n plus 4. And this has to be less than 1. Okay, so note that I did not put an absolute value here, even though it's an absolute value, because I know that n is approaching infinity, so it's definitely positive. Everything's positive here. I don't need to put it. You could put the absolute value if you want, but it's useless. Okay, so at this point, well, what is this limit here? Limit 3n plus 1 over 3n plus 4. If you do L'Hopital's rule here, you will get that this limit is 1. Okay, this limit is 1. So what do I have? I have that the limit as n approaches infinity of this an plus 1 over n is less than 1, only if the absolute value of x minus 2 is less than 1. That's what happens. Okay, because the limit there is 1. Are you good? How do we solve this inequality? Okay, so this is something that you should have done in high school. So the absolute value of x minus 2 is less than 1 means that x minus 2 is between what and what?
Minus 1 and 1.
Very good. Minus 1 and 1. Okay, so I have to isolate x, so I will add 2 everywhere. So if you add 2 here, you get 1. If you add 2 here, you get x. If you add 2 here, you get 3. Oh, so now I see that x needs to be between 1 and 3. For this series to converge, the x needs to be between 1 and 3. You good? We're getting somewhere here.
Sir,
Yes?
I'm just wondering, how did you find the lower bounds again of the squeeze?
The
Or-
minus 1 here,
Yeah, here, yeah.
it's always minus this one.
Okay.
If it was 5, it would be minus 5 to 5. If it was 10, minus 10 to 10.
Also, the limit on the bottom right, you just evaluated to be 1, right?
Yeah. I did L'Hopital's rule. Yeah, it's a very easy limit. Okay. There's only one problem with this. It's very good. X is between 1 and 3, perfect. But what happens when x is 1 and what happens when x is 3? Okay, when x is 1, if you plug in x is 1 here, your limit will be 1. Your ratio test will give you 1, which means that it fails. Same thing, if x is 3, you plug in 3 in here downstairs. 3 minus 2 is 1, so you'll get 1 as well. And these are places where, these are values of x where the test fails. So I need to check them manually, each one. Okay, so let's see what happens at x equals 1. Okay, so at x equals 1, the series becomes what? So let's go back to our initial series and plug in x equals 1 here. Okay, so the series becomes sum n equals 1 to infinity, negative 1 power n times, well, 1 minus 2 is negative 1 power n over 3n plus 1. That is the series n equals 1, sorry, it starts at 0, 0 to infinity of, okay, negative 1 power n times negative 1 power n is just 1. So it's 1 over 3n plus 1. And this series, okay, if you do your limit comparison test, you'll see that it behaves like 1 over n, and you will see that it diverges. Okay, I'm not going to do the test here. Diverges, okay, because of the limit comparison test. Okay, you could try it. Okay, you could compare it to 1 over n, which is the harmonic series that diverges. Okay, so this series diverges. So at 1, if x is 1, the series does not converge. So 1 is not included in my interval of convergence.
Sure.
Yeah.
Could you explain how you got 1?
Which one?
The last line.
Oh, this one here?
Yeah.
Because, so negative 1 power n times negative 1 power n is equal to, so I multiply the inside, so negative 1 times negative 1, all this power n. But negative 1 times negative 1 is 1 power n, and that's 1.
I don't get how 1 power n turns to 1.
You don't get what 1 power n turns to 1?
Yeah.
It's 1 times 1 times 1 times 1 times 1
Oh,
n times.
okay. Okay.
Yeah. Okay, so now at x equals 3.
Sir,
Yeah.
isn't 1 to the power of n at an indeterminate form?
If n is infinity, yes. But here n is not infinity.
Doesn't it reach infinity at one point?
No. It's not, I'm not doing the limit here. If, don't get mixed up with 1 plus 1 over n power n. That's also 1 power infinity. But that's not a real 1 here. You understand? That's approaching 1 and approaching infinity. Okay, this is approaching 1. But this limit, I could even write like this: limit n approaches infinity of 1 power n. That's 1. That's not a problem. If I know that this is 1, not a problem. Understand? It's just that if this 1 here is approaching 1, then we have problems. Okay, same thing. If you have limit n approaches infinity of 0 power n, that's 0. That's not a problem. That's a fixed, that's real 0. 0 is not moving. It's absolutely 0. Do you understand?
Yeah,
Sorry,
makes sense.
It's a good question. Yeah, sorry.
is that because 1 plus 1 over n, it converges towards 1 but it never really reaches it?
Yeah, in part. Say it this way. Okay. Any other questions before I go to the case where x is 3?
Yeah, sure. Why is
Yeah.
it limit comparison test?
For what? For here?
Yeah, where you say it's divergent.
I don't know. That's the test that I'm using. Which test would you use?
Well, like, since we're like basing off like it behaves like 1 over n, wouldn't you say like it's harmonic?
Yeah, but you have to prove it.
Oh, okay.
You have to prove it. I agree with you. It behaves like 1 over n, true, and that's what led me to conclude that it's divergent, or to assume that it's divergent. But after that, you have to prove it, and for that you need a test. So I'm telling you, the test that you're going to use is the limit comparison test.
Oh, okay. Okay. Thank you.
Okay, try it. The point of this exercise is not the limit comparison test, so I'm going fast. It's the power series problem is long enough as it is. Okay, so you'll do it on your own. Okay, it's not difficult. So at x equals 3, what happens? Okay, so it becomes, so the series, same thing, the series becomes, becomes what? Sum n equals 0 to infinity, so -1 power n. Now x is 3 here. 3 minus 2 is 1, so times 1 power n over 3n plus 1. And that's equal to sum, so exactly like the question you asked. 1 power n is just 1. So this will be -1 power n over 3n plus 1. And does this converge or diverge? Okay, so you haven't done your exercises yet, because you have to do it right away. So this converges because of the alternating series test. Okay, it's an alternating series, -1 plus 1 minus 1 plus 1, and the term 1 over 3n plus 1 limit goes to 0. So the series converges. Okay, we'll go back to the flow chart that I gave you last class with the alternating series test, and you will see right away that it converges. And now I can answer my question. And so my interval of convergence will be, so from 1 until 3, 1 is not included, but 3 is, because it converges at 3. 3 is included. And the radius of convergence will be the half the length of the interval. 3 minus 1 is 2. 2 divided by 2 is 1. That's my radius of convergence, and we've done the problem. So second example. course, same question, find the interval of convergence and the radius of convergence of, let's say, n equals 1 to infinity. Let's do x minus 3, no, x plus 3 to the power of n divided by n plus 3 to the power of, let's say, 5 power n. So let's do the ratio test. Limit as n approaches infinity. Absolute value of an plus 1. So x plus 3 power n plus 1 over, so n plus 1 plus 3, so n plus 4 times 5 to the power of n plus 1, and then times this flipped, n plus 3, 5 power n, and here I have x plus 3 power n, and this has to be less than 1. Okay, this is my setup. Okay, that's my ratio test, an plus 1 over an has to be less than 1. So this means that limit n approaches infinity, and now let's simplify the inside. So x plus 3 power n plus 1 over x plus 3 power n is just x plus 3 times n plus 3, and on the bottom I have n plus 4, and okay, the x plus 3 power n disappeared, and then 5 power n over 5 power n plus 1 is just 5 on the bottom. Okay, so this is what I get when I simplify this fraction. Okay, let's pull out whatever doesn't depend on x, on n, I mean. I pull that outside. And so I have the absolute value of x plus 3 is out, over 5 also is out, times the limit as n approaches infinity of n plus 3 over n plus 4. This has to be less than 1. Okay, but this limit, of course, is 1 if you do L'Hopital's rule. Which means that the absolute value of x plus 3 has to be less than, right? Over 5 has to be less than 1, so this has to be less than 5. Which means that x plus 3 has to be between -5 and 5. If you minus 3 on each side, you get -8 less than x less than 2. Okay, is this what you got? Did some of you get this?
Yeah, I made it to this
Yeah.
point.
Okay, that's great. So if you got that far, that's already good. So let's see now at x equals -8, what happens? Okay, so the series becomes what? Sum n equals 1 to infinity. And if I plug in -8 inside here in the x, I get -5 power n over, and on the bottom I get n plus 3 and 5 power n. Okay, and this is equal to sum n equals 1 to infinity. So negative 5 power n over 5 power n is like negative 1 power n over n plus 3. And this series converges, diverges.
Convergence.
Very nice. What test? Okay, because of the alternating series test. Okay, so this is an alternating series. So it converges because the limit at infinity of 1 over n plus 3 is 0, right? The limit of an is 0, series converges.
Sure.
Yep.
Should we conclude that it's always going to be alternating test we're going to be using?
I don't know. Why do you want a general rule? Always. Each case, treat it. I think it's always going to happen. I
Okay.
think you're right, but I don't agree with trying to find a recipe. Always this, then that, always no. Just each case, treat it with respect. Okay?
Mhm.
Sir,
Yeah.
do we need to show that it converges with the test?
You mean this here?
Yeah, do we need to prove it?
Yes, you have to show that it converges. It's just that we don't have time, but you have to do since, right? Because you have to write limit n approaches infinity of 1 over n plus 3 is equal to 0. Then the series negative 1 to the n over n plus 3 converges. Yeah, that's this here. That's the alternating series test.
Okay.
Okay. At x equals 2, what happens? So the series becomes n 1 to infinity. So 5 power n over n plus 3 times 5 power n. The 5 power n's disappear. Sum n equals 1 to infinity of 1 over n plus 3. And does this converge or diverge?
Diverges.
Very nice. Because what? Which test?
ICT.
What? Which one?
The ICT test.
So the limit comparison test, right? Okay, you compare it to the harmonic series. Okay, you divide it by 1 over n, you'll see the limit will be 1, which is less than infinity. Therefore, this one diverges as well. Okay. So my interval of convergence will be from -8 to 2. And -2 is included. -8, sorry, is included, but 2 is not. And what is my radius of convergence? What is it?
3.
I think it's 5. It's 5?
Yeah, it's 5.
It's 5. Okay, so it's the half the length of my interval. Okay, or you could see it from here. Absolute value is less than 5. That's going to be radius always.
Yes, sir.
Yep.